And future astronauts to load onto the Starliner. Hopefully we'll see that launch sometime in second quarter of 2017 with a crew launch later that year. We started groundbreaking January of this year. So we've come a long ways considering we've launched 7 times. An 8th will occur in a couple of days with the Cygnus launch. But we started our groundbreaking in January, finished it up around August, and then started actually stacking the steel you see here in September. Now that steel, most of it was constructed up the road about 4 miles, and we constructed 7 tiers. Each tier was fully outfitted with the elevator shaft, stairs, grading, etc. And then transported up here. We started the first stack on September 15th. What they're working on today is all of the outboard steel. So once we got the 20 by 20 framework built and constructed, all of this outboard steel is now being constructed. Today they're actually finalizing and securing for the upcoming launch. So bolt inspection, final bolting up of the roof lines, trusses, and then a final walk down and cleaning prior to the launch. So that's where we are today. We still got quite a bit of work to do. We've got 4 more erection plans in regards to the outboard steel to complete after Cygnus, and then all of the outfitting in regards to pulling all the wire cables and finalizing all the interconnects inside the tower. So that's where we're at. So this is your opportunity to ask questions of Steve and I, and we will open the floor for any questions that you might have. You guys are less talkative than that earlier group. Sure, we could talk a little bit about it. So again, this is the crew access arm. We are currently fabricating that arm over in Oak Hill, Florida. We've had piece parts come from all over the country. And we built a test stand in Oak Hill, and that test stand is going to be used to completely outfit the arm and that will control the arm. And so over the next several months, we'll be testing that arm, running it through its paces at Oak Hill, and then we will bring the arm here in the summertime of 16, integrate it with the tower, and get it finalized for our first use next year, or year after next. We also have a current baseline design for emergency egress. So this is a 1/84th scale. So what you see right there, this is 1/84th the size, and it is to scale. So everything that's on here is exactly what it looks like on there. Our 3D print office took care of this for us. But our current baseline design calls for a slide wire basket system, similar to what Shuttle had, but a little more elaborate because it's involving some lessons learned from Shuttle, and plus we don't have the same amount of real estate that Shuttle had. And so that system will egress from level 12, and it'll end up in the parking lot in the Ready building that you guys passed coming in. The tower itself is 201 feet tall, and when it's completed, we'll have nearly 1 million pounds of steel and well over 1,000 cubic yards of concrete involved in the process.
How much damage has been done to the tower after each launch?
None. So surprisingly, so the question was how much damage to the tower after launch? 0 damage. You know, it looks like it's relatively close, and again it is. I mean, we're 40 feet away, but these rockets don't drift a whole lot. So, and if you look up above, you can see the catenary system, and we got to get through that hole up there, so it can't drift a whole lot. But so launch drift isn't bad. Overpressures on this corner is about 4 psi, so it's not that significant. So, any other questions? I'm sorry. Sometime around the second quarter. When will we stop working for this next launch? So they are doing their final bolt ups of the steel we just erected. Yeah. Normally we'd be completed yesterday. Okay. So we're a little bit behind. We lost a couple days to weather leading up to Thanksgiving. Had significant winds out here. So they are doing their final bolt up. They'll be coming off the tower. We've already walked the tower down once to make sure everything is secured. And then they'll bring the crane and park it in the back end of the pad deck behind us, and then we'll do a final walk down with our customers tomorrow. So we're a little bit behind, but we've got plenty of time to wrap things up in the next phase.
smaller pipes that are sticking out of the water main.
So what we did is you know, we wanted to make this as maintenance free of a tower as we could. So all the piping that you see on the outside, on the bottom, and all the way up through is a washdown system. So shortly after the vehicle clears the access tower, we're going to put water on the tower and wash down any residue that is left behind from the solid rock. No, sir. So all of the acoustic suppression will come from the SWS system on the mobile launch platform, as well as the trees surrounding the pad deck here. We don't need any cooling from heat. You don't get a lot of heating. You get some, but not enough to cook your steak.
How long before it clears the tower?
So how long does it take to clear the tower? A lot of it depends on the vehicle configuration. So if you have a 501 configuration, which is basically a 500 series with one Centaur engine and stuff, those typically take the longest to clear. It could be upwards of 17 seconds from ignition to clear. It'll be interesting with Cygnus. Cygnus is a fairly heavy payload. I would be guessing if I told you an answer now, but it's probably going to be in that same realm. Other questions?
For those of you that are not very familiar with the Commercial Crew Program, as you're aware, a couple of years back, the shuttle program was retired, and we used to take our astronauts to and from the space station using either the shuttle or the Russian Soyuz capsule. With the retirement of the space shuttle, we were briefly without that capability from here in the States. The Commercial Crew Program is intended to give us that capability back. The launch tower you see behind you is United Launch Alliance and Boeing joint project to provide access to the CST-100 spacecraft mounted atop the Atlas V rocket, and they should be flying us to the space station starting in 2017, sometime early 2017. It's kind of far out to get it that close. But that should give us the ability to do smoke and fire from here in the United States and take our astronauts up to and from the space station that way. And that frees up NASA to work on other projects, such as the asteroid rendezvous and Moon and Mars and other such things like that. Some of the areas that nobody else is working on.
Which one of the Voyagers left from this pad? Was it 40 or 41?
41. Yeah, this pad, if I understand correctly, the Voyager missions launched from here. The Viking missions that landed on Mars launched from here. The Dawn mission that's circled an asteroid and is now circling a dwarf planet launched from here. And the Curiosity rover launched from here. And our mission that just passed Pluto the other day also launched from here. So this pad has seen a lot of activity in the past, and it's about to make some more history as the first one on this side in many, many, many years to launch humans into space.
What's the purpose of the braces and structure there?
Which bracing structure are you talking about?
It's like you get the steel I-beams.
We call that the Welling Wall, and it actually provides shielding to the environmental shelter behind us.
Oh, okay. Do you expect the overall cost of launching the rockets for the International Space Station from here to compete with what the Russians are charging now? And I know that it costs a lot for us to use the Russian facilities, but are there plans for NASA to also offer these services, for other countries that would like to send stuff like research to the International Space Station?
The answer to both of those is yes. It is going to be more cost effective to launch from here than to launch from Russia. I could quote numbers, but I think it's 80.
Current Russian seats are 81 million.
81 million for a Russian seat
And
right now.
our
We're looking at
current seats
58.
are about 58. Yep.
Okay, so we're looking at 58. There's about a 20 million saving per seat, and if we're sending up 4 astronauts at a time, that adds up over many years. The other difference is that every one of those pennies stays here in the United States. We invested in our own economy and our own infrastructure instead of sending it overseas. So there are many, many advantages to doing this.
So there are some Russians freaking out right now.
Well, they still have.
Lose money, right?
There's still going to be an option in the future. We never want to be single string. Never want to have only one way to get there. They will continue to provide launch services. They may or may not take our astronauts in the future, depending on what operational needs might be. We do intend to take international astronauts up with us from here. So it would be a shared effort between NASA and other international partners.
May I ask you a question? So, the astronauts training now is worse than the Russian situation. How much training station operations? Is there going to be less of a greater communications barrier?
Okay, the question is, currently we do a lot of immersive Russian training in order to be able to operate the space station. But that's not only because we launch on a Russian vehicle, it's because we're going to spend 6 months with a half Russian crew. And operations happen in whichever language the commander of that particular increment happens to be. If it's a Russian commander, operations happen in Russian. If it's an American or European commander, they happen in English. So they still have to have all the immersive operations. They need to be able to read all the instructions for the Russian-built equipment, be able to understand all the Soyuz capsules because they're still there and can be used for evacuation. So the need to be completely immersed in each other's culture remains the same.
I see an upper rocket for escape for the capsule. Is the CST-100 going to use a perimeter pusher system?
Yeah, the CST-100 has an integrated launch escape system, and it's a pusher system. It sits underneath the rocket, and that way it's not something that you jettison on the way up. It stays with you all the way. And it can be used for a variety of things. If you need to reboost to do other things, it's available to you.
Will it be part of the actual
CST-100 is not currently planned to be an active landing system. It's going to come down on parachutes. So it's not part of this particular design.
Does the crew access tower, does it also provide like umbilical access to the CST-100? Or is it just crew access?
Pretty much crew access. All the umbilical access will come up through our normal spacecraft umbilicals through the rocket. We do have some ECS type umbilicals and cooling loop umbilicals that I'll go over, but from an electrical and a transmission perspective, I'll go through the vehicle, launch vehicle.
Okay.
Yeah,
Yes, sir.
I had a question. Is there going to be more cooperation between the Chinese space program and the rest of the world?